So the first thing that I want to do is I kind of want to go over your worksheet. You already have this worksheet. Remember that this worksheet is due tomorrow. So you've had class time to do it. Suck it up, people. Don't feel sorry for you if you have one done and the other one's not. All right? So this is due tomorrow when you walk in this classroom. All right? You can just go put it on my desk. All right, so I'm going to talk about this worksheet. This is a very good review for your test. Okay? So just going to kind of go back because we have been on a week break. So just going to make sure I'm bringing to mind things that you should know. Find the domain and the range. If you needed to, you could graph this function using the your transformations, right? With an X, it is an X, left or right, opposite, not up or down. All the reflections and all that kind of stuff. So you could do that, finding your domain and range. You also have restrictions. Don't forget restrictions. Okay? Sean?
Do we have to do both set notation and interval?
I would, yeah, let's do both set and interval. Just do them side by side. Okay? Set and interval. All right, look at this one. Use a calculator to determine the open intervals on which the function is increasing, decreasing, and remaining constant. What does an open interval mean? No idea.
It's open to new things.
It means you're only going to use what?
One.
Two.
Parentheses. Yeah, parentheses. Not a closed interval, not inclusive, you're not using brackets. Remember we said when you're talking about whether a function's increasing, decreasing, or remaining constant, you only use parentheses. That's what that word open interval means, using your parentheses. Okay? Look at these down here. Use your calculator and approximate to 2 decimals any relative maximums or minimums. I want the point. Don't just put the at y value, okay? I want the point. All right, so I just want to make sure that you understand something. This is a cubic curve. This is a cubic function. At most, how many humps will this thing have?
2.
2 humps, okay? Look at this guy right here. This is a 4th degree. Now, y'all look, if that was just x to the 3rd plus 2, would it have any humps?
No.
No. So the more junk you put in there, that 3x squared, if it had a minus 7x and stuff like that, the more stuff, that's what creates those. Okay, so look at this guy right here. He's a 4th degree polynomial. How many humps will he have?
4.
3.
3. At most 3 humps. Now he may not have 3 humps. Do you understand? Now obviously he has a lot of junk, so he's going to. So I want to show you something. So here's the equation. There's the equation right there, okay? I know it's a bad picture, but whatever. So I'm going to go zoom 6, which is a standard 10 by 10. And then I look at it. Does it look like a parabola? Except what? Do you see how weird this looks over here? Yeah, do you see how you look at that and you go, whoa, wait a minute. A parabola is what? Symmetrical? It's the same on, is this the same on both sides?
No.
Well, he's not the same on both sides. So I'm like looking at this going, wow, something's going on down here. Do you know how to zoom into this area? Yes or no?
No.
Yes.
Okay, so I'm going to show you how. So zoom, see the zoom button? Zoom, and 2 is in, so I'll press a 2. Now, he did not zoom in anywhere. Okay? He's asking you where you would like to zoom in. So when I did that, he's popped up a little plus sign in there. This is the coordinates of my plus sign. I'll show you what he looks like. See him right there? He wants you to put this plus sign whatever general area you want to zoom into. Well, obviously, I think there's something going on down here. So I'm going to zoom into this area down here. So I just put my plus sign down there. And then I press enter. Now he zooms into that area.
Whoa.
Okay, so now when you do that, do you see that there are 2 mins and 1 max in that area? You see what I'm saying? Y'all look. See this guy and this guy? Those are my 2 mins. In between those 2 mins, there has to be a what? A relative max. Okay? So, if you want to, you could go and you could zoom in again. If you're like, picture. I'm gonna zoom in again. There's one min, there's a max, and there's gonna be another min
So there
over
will be
here.
two sets of points for min and
That's
1 point for
exactly
max.
right, okay? So what happened was that a lot of kids graphed that, and they found one minimum and no maximums, all right? So I want you to pay attention to what kind of curve it is. Y'all, the maximum, now does that mean it's going to have that many humps? No, it means it possibly could, but if you see a bunch of junk in there, like the x cubes, the x squares, the x's and stuff like that, that's what's making that happen, okay? So if you, an x to the fourth, the number of humps it has is one less than his, the degree, which is the highest exponent. So he could have 3 humps. He obviously has 2 down here and then that one in the center, so he had 3. All right, everybody understand? I'm trying to keep you from missing that one. That one's missed quite often. This today, even and odd, we're gonna do those today, okay? This is just a word problem. You should be able to do that. This one, I'm doing this just exactly like I'm going to do on your test, okay? So you might want to write this down. Identify the common function. I want the name. So in this first blank, I want the name of this function, okay? And I want you to write an equation, which is the parent function. All right, so the first blank is the name, and the second blank is the equation of the parent function. Now, I'll give you bonus. Would it be nice to start the 6 weeks out with some bonus points?
Yes.
Yes, it would. I'll give you bonus points if you can write the equation of the actual
I
graph.
hope that's what it was.
Okay?
Me too.
So, I know, that's why I'm going through and clarifying, okay? I'm going through and clarifying so that you don't. And this is just the way it is on the test too. On the test, I'm asking you to name the function, I'm asking you to write the equation of the parent function, and then I'm going to give you bonus points if you can write the equation of the actual
Wait, like
graph.
a memory test?
It's
Is it
like
right?
a memory test, like you write the name,
Yes.
and then the function, and then bonus points if
Yes.
you write the
Mhm.
actual.
Same thing?
All right, this is a piecewise function. Should you be able to do it?
Mm-hmm.
Yes, we've already had a test on that. That should be a learned skill. These right here, we're fixing to do these today, okay? These right here. We've already done composite functions, so you should be okay on those. And then these are composite functions also in domains, all right? And then this is find the composite function, and then tell me what f of g of 3 is. So after you found the composite function, which you did in number 28,
You plug it in.
then you're just gonna plug 3 into it, okay? Now, could I cheat and just go from right here and write my answer down?
What?
Y'all look, do you see where it says this? It's because I asked. I said, hey, which one of these guys is the input function?
3.
3. What? No, stop.
Follow along.
Which one of these functions is the input function, F or G?
G.
G. The second one is always the input. You're putting him in the first function, okay? So what you could do is go to this input function and put a 3 in,
And that's
all right? So what is 3 squared?
9.
And then you can take that 9 and substitute him in the F function. What's 9 minus 1?
8.
So is square root of 8 the answer?
No.
No, because
Two
that's
square
not
root
a
of two.
simplified radical,
No.
okay? So 2 square root of 2 would be the proper answer. Do you understand? Okay, so 2 different ways to do those. All right, we've already talked about relative mins and maxes, so I'm not worried about that one. So we need to talk about even and odd functions. All right, we've already done this. So this is also on 1.3, okay, section 1.3, and we're gonna talk about even and odd functions. Okay, now this morning we did even and odd functions, and the kids were like, so, like, now we know how to tell even and odd, what does that do for us? And I said, well, if you were graphing these without a calculator, it might be helpful to you, okay? It might be helpful to you. So, but we're not, but you are going to have to, on your test, tell if they are an even function or an odd function. All right, so hang on just one sec. Okay, so even functions right here are symmetrical. Does symmetrical have two ends? Yes? To the y-axis. Okay? They're symmetrical to the y-axis. Think about this. Think about a parabola. Okay? He's an even function. Are all parabolas even functions?
No.
No, they're not. Okay, so don't go, oh, all parabolas. No, they're not. This one is. All right? Because this vertex is on the y-axis. So this point right here is just like this point right here. You see what I'm saying? That's symmetrical to the y-axis, even functions. Odd functions are symmetrical to the origin. All right? They're symmetrical to the origin. So here's what that means. Let's write this down. If this point right here is x, y, what's this point right here?
Negative xy.
Yeah, negative x, y. Okay? That's symmetrical to the y-axis. That point stays the same, and then it just flips over there, and the x becomes the opposite. All right, so here's what symmetrical to the origin looks like.
That's cubic.
Okay? This point, it could be, yes. So this point we'll call x, y. What is it down here?
Negative x.
Mhm. He's negative x and negative y. You see him? So this point, negative x, negative y. Symmetrical to the origin. That means he flips over the x-axis and the y-axis. That's the origin. Okay? Pardon me. So some kids want to know, how come it can't be symmetrical to the x-axis? Does anybody know why?
That's a function.
It's not a function.
Yep,
Yeah.
it's not a function. Let's say you have this guy right here, and if he were symmetrical to the x-axis, he would also flip down like this. Is this a function?
No.
So that's why we're not talking about that, okay? He is not a function. All right, so we're not gonna go, graphing, you can go kind of by looks and tell if a function is even or odd, not the best way. It can help me graph, because if I'm graphing and I don't have a calculator to graph, I know more points. Do you understand that? Once I know some points over here, I can flip them over the y-axis, or I can flip them over the y-axis and then flip them over the x-axis and have more points. I know what it's gonna look like. But we're gonna go algebraically, okay? Algebraically, how do you tell if a function is even or odd? Well, here it is. I'm going to give you a function. You are going to find f of negative x, which just means that every place there's an x, you're gonna put what?
Negative.
Negative x. If these two things right here are equal, then it is even. Okay? If those are not equal, then you will have to find this, the opposite of f of x. Now, all that means is that you're going to take this function and change all of his signs. Okay? If these two things are equal, that means it's odd. If none of them are, then that means it's neither,
It's not a
or
function.
neither, however you say it. Okay?
Neither.
Anybody have a question?
Oh.
This is easy, guys. Okay, this is easy peasy. All right, so here we go. In section 1.3, we're going to start with example 10. Okay, and I'm going to do A. Here's what I want to know. Is it even? Is it odd? Or is it neither? Okay, is it even? Or is it odd? Or is it neither? So here's my first one. G of x is equal to x to the third minus x. X to the third minus x. Now, here's what I do. Every time I just go, all right, well, I've already got this thing, so I'll need to find this and this. So I just write down, I need to find g of negative x and the opposite of g of x. Has everybody got it? Okay, so how do I find g of negative x? What do I do?
Plug in.
Yeah, I go over here to the g function, and in place of every x, I'm putting negative x. When you raise negative things to a powers, what do you have to have?
Parentheses.
Parentheses. Please don't forget that. Okay, so this is going to be negative x raised to the third power minus negative x. Are you with me? When you raise things to odd powers, they keep their sign. If it's positive, it stays positive. If it's negative, it stays negative. Okay? Or negatives raised to an odd power are always what?
Negative.
Negative. Whichever way you like to think about it. What's the opposite of a negative x? Are these two equal? Then guess what? He's not even. Right? He's not even. We don't know if he's odd yet. We're going to go over here and see. This guy, all he does is say, hey, take the opposite of this function. So don't forget the parentheses, because you have to change every sign. You can't just slap a negative on the front of it. Okay? That's only changing the first term sign. What's the opposite of a positive x to the third?
Negative x to the third.
What's the opposite of a negative x? Are these two equal? So, my answer is odd.
Now, if those didn't equal, it would be neither.
It would be neither. If these two are equal, it's even. If these two are equal, it's odd. All right, anybody got a question? Okay, here's yours.
I can't do it.
All right, h of x is equal to x squared plus 1. I want to know, is it even, odd, or neither? Go. You have 40 seconds.
I didn't remember.
Will it ever be all three, or not all three, all, like
What?
both? Well, can it be odd and even?
No.
Alright.
No, it cannot be. Okay, so I'm going to start working it. So the first thing, oh, sorry, not a G, it's an H. So H of negative x. So everywhere there's an x, I'm going to put in a negative x. So this is negative x squared plus 1. Anytime you raise something to an even power, it's always what? What?
Positive.
Positive.
Sorry.
So this becomes positive x squared plus 1. Are these equal to each other? Do I need to do the last one? People, if you already know what it is, why do you want to do more work? Okay? That's crazy. These are
Check
equal
yourself.
to each other, so it's what? Even. Anybody got a question? Everybody okay? All right, here's the next one. F of x is equal to x to the third minus 1. Even, odd, or neither? Is it even?
Yeah.
No. I put my negative x in. A negative raised to an odd power is always negative, so they're not alike. Now I'm going to do the opposite of f of x, which means I'm going to change all the signs. Negative x to the third plus 1. You have to change all the signs, okay? Are these two equal? So what's my answer? Are we okay? All right.
Why am I
So-
gonna miss this on the test?
I have no earthly idea, but kids do, and it's insane. I'm like, oh my gosh, this is so stinking easy. What is wrong with y'all? All right, so here's the next one. These are out of your book, okay? These are out of your book. So the first one I'm going to do is number 49, and it looks like this. F of x is equal to x to the second plus 2x minus 3. I want to know, is it even, odd, or neither?
Do it by itself.
Yeah. We're gonna do 4 of them really quick, and then I'm gonna teach you the other stuff, and, then I'll be through. Hopefully we'll get finished, I think we will. Was it even? No. Was it odd?
No.
So what is it? All right, everybody okay? Ask me questions, guys. If you have questions, you need to ask me questions.
Wait, why is that a plus 3 and
Sean.
not a minus?
So
Because you have to change every sign, Eli.
Not just the.
not all the quadratic functions are even.
No. If they put an X in there, it's not. Okay? Because think about it. This guy right here is moving this guy left and right of that y-axis. So can he be symmetrical to the y-axis if you move the vertex of the quadratic left or right? No, he's not. So as soon as you move that guy left or right. Now, does this mean that it moved it left or right too? No, it doesn't. There's a formula that you can use to do that. We used to teach that in Algebra 2, but we, chose to teach different things now, so. All right, here's the next one. Are you ready? I'm gonna skip one of them because I think it's okay. I don't think it's but I wanna do 2 problems that I think can be tricky. So here's the first one. This is number 53. I obviously skipped 51. F of x is equal to x times the square root of 1 minus x squared. F of x is equal to x times the square root of 1 minus x squared. Okay. First of all, be careful that you don't think that that sign right there makes that sign a positive. You have to raise to powers first. So a negative x squared is a positive x squared, and then it's minus x squared. Does everybody understand that?
Whoa.
All I did was put negative x in for every x, so that's negative x. Negative x squared is what?
Positive A.
Positive x squared. So this becomes minus x squared.
Can you?
Is it even? No. Okay, so here's where the carelessness is going to happen. When you find the opposite of this function, am I allowed to distribute a negative throughout that radical?
No.
When I take the opposite of the function, what is the only thing that it does?
Change the outside.
Yeah, it just changes this guy right here to a minus x. That's all it does. So what?
It's all.
It's odd. All right, anybody got a question? All right, let's try the next one. He's tricky also. Four x to the 2/3. Even, odd, or neither.
Alright.
What happens when you write something to the 2/3?
I'm done.
You do have to remember this, that a rational exponent, which is a fractional exponent, just means that, what grows on the bottom?
The root.
Roots. These are roots
Whoa.
and powerful things on top. These are powers. Okay? Roots grow on the bottom of the tree, so these are roots. You're taking the cube root of that guy, and then you're going to square it. Now really, what is the only thing I'm thinking about when I do this stuff right here?
Baby root.
That sign. Okay? So listen to this. Alright, listen to this. When I take the cube root of a negative number, what will my answer be?
Positive. Negative.
Negative.
You're right. Not you, Colton.
I know.
Alright, so, if you didn't know, then what you should have said is, oh, I don't know, what's the cube root of -8?
2.
No,
-2. What's the cube root of -8? -2. Okay, what's the cube root of +8?
Positive.
+2.
Oh,
So
wow.
odd roots, listen, odd roots keep the sign. Okay? Odd roots keep the sign. So if I take the cube root of this -x, that will be a negative number. Do you agree with that?
Yes.
And then when I square that negative, what will it become?
Positive.
So that's it.
It's even?
Mhm. Alright, anybody got a question?
They
So
know.
basically you just do the bottom and the top.
Mm-hmm. I always do the bottom first. I usually do the bottom first.
Okay.
I mean, you could have done the top. The order really doesn't matter. Could you have done the top first and said when you square a negative, it becomes a positive, and the cube root of a positive is a positive? Yeah, it's all the same. Okay, so now we're moving on, people. 1.5. Now, you've already learned the most difficult part of 1.5, which was compositions of functions, okay? You've already learned compositions of functions. That's F composite G, G composite F,
Is that
and
one
you learned how to find the domain and everything. So that's going to be on your test. It is on your review, all right? So make sure you know how to do it. So what this part of the chapter that we didn't talk about is called combinations, not compositions, but combinations of functions. Okay? Combinations of functions. So think about the different ways that we can combine numbers. There's 4 of them. What are they?
Add, subtract, multiply, divide.
There you go. So all we're going to be doing is adding and subtracting and multiplying and dividing functions. That's it, people, okay? It's not going to be really hard. When you add and subtract, you collect like terms. When you multiply, then you'll have to collect like terms too. All right, so here's the first one. I'm going to show you the different ways to write it, okay? Just so that you're familiar with it. So this is the way you see it a lot of times, f of x plus g of x. Sometimes they'll write it like this. It means the same thing, f plus g of x. Okay? It means the same thing. Some kids look at this and what will they do to it? They'll add the functions and then multiply it by x. No, that's not what that means. It just means add f of x and g of x. Okay? the difference. This is how you know. You know, I always tell y'all I'm such a terrible numberer. I can't number things. Look, these are my notes. All right, look. 1, 2.
4. Wow.
I know, it's terrible, isn't it? I don't know.
How are you a math teacher?
I have hardly idea. Hopefully not for long, so here we go. F of x minus g of x. I'm in my last days.
Taking it easy on us in your last days.
F minus g of x. I'm gonna go out strong, Eli. Okay? The third one is a product.
Keep in mind, you still have next year. You can go out strong next year.
I am.
Yeah, it's not this year.
I'm gonna go visit them this summer, and if they tell me that it won't serve me any purpose to go out, that this year will be just like next year, I'm like, see ya. I don't think they're gonna say that, cause I have to make some kind of 80 rule in Texas. And, I won't make that till I turn 60, so.
Wait, why are you gonna make an 80 rule when you're 60? You're
Because of
missing
your
20
years
years.
of service and your age have to add up to be 80 in order to.
So you've been
try-
teaching for 20 years?
You have to work for 20 years.
Well, I've only been teaching here for 13 or 14 years.
That's like,
Yeah.
yeah.
And your other state, it doesn't count.
No, I had to, but I bought 6 years.
You can buy years.
Well,
Cash?
yes, you had to pay cash, it was expensive, but,
How do you do that?
Not like 3 years.
we saved a lot of money. But,
So wait, you bought 6 years?
I bought 6 years, so that I wouldn't have to teach till I was 95 or something.
Oh, yeah, okay.
See, all right, because maybe count my Arkansas years.
I would have bought
Aw.
all of it,
Can we go back?
and I
Okay,
would
so
have my
product
first-
is multiplication, so that's F times G of it. Now, how am I gonna know that this is multiplication and not a composition?
Because it's
Oh,
on
God.
circle.
Yeah, it's not a little open circle. Not an O, is it? It doesn't say
No.
fog and golf, like y'all call it. Okay, but it kinda looks like that. All right, here's the next one. This is the quotient.
Dog is fun to drive it in your head like
So it's going to be f of x divided by g of x, or f over g of x. So just different ways of expressing them. All right, you'll see them both ways. I just didn't want you to see the second way and go, whoa, what's that mean? All right, so let's try some of them. We're probably just gonna go down the line and work some. So
Ms.
here we
Davis,
go.
I'm still waiting on the day that I see you just cruising on your bike going like 80 down the highway.
Oh,
I
Lord,
just-
if I'm going 80, you know I'm fixing to wreck.
Let's get her an electric skateboard.
No. So f
It's
of
time
x
to
is equal
try
to.
to-
I do like to try and ride those little, what are those things called?
Hoverboard?
Yes. I like those.
I wanna see you.
I like those. I've ridden one and I'm okay. On the carpet, I'm really good, but on the hard floor. I think, I've thought about asking for one for Christmas. I'm afraid I'll hurt myself really bad, but I think it will.
She said broke collarbone with the,
I wanna
Mike
see-
Tyson
I
broke
wanna
his
see
back.
that ring ride.
Yeah.
That's what I wanna see.
Broke his back. That's gonna be Miss Davis. It's gonna be like the year she retires.
better knock on something.
No. Okay, so here's what we're gonna do. We are going to find f plus g of x, then evaluate when x is 2. So how many answers?
2.
2 answers, guys, okay? Know what they're asking for, 2 answers. All right, so what does this mean they want me to do? Add those two functions and then multiply them by x? No, people. It just says, hey, what's f of x plus g of x? All right? So f plus g of x is equal to f of x plus g of x. Are you with me? Yes? Yes, everybody okay?
Mm-hmm.
All right, so who do I start with?
4x.
What? X squared. You always start with the highest power and then go down.
You right.
Okay? So he's my highest power, so I start with my x squared. Okay? And then I go, are there any x's? Yes. What is 2x plus 2x?
4x.
I like to mark mine out as I go, because then I don't really look at them anymore, it makes it easier. So then I do my constants, what's a positive one and a negative one?
12.
So this is my answer, all right? So this is one answer. And then they want me to find, could I have said it like this? F plus G of 2. Is that the same thing?
It's
Yes.
12.
So what will I do?
Plug 2 in.
Yeah, you just plug 2 in over here. This is F plus G of x. So I'm gonna go 2 squared plus 4 times 2. What's 2 squared?
12. 4,
Plus 4 times 2 is,
8,
and 4 and 8 make
12.
12. So there's my second answer. Anybody got a question? Okay, so let's do a subtraction problem. This is example 2. I'm going to use the same functions up here, okay? But this time I want you to find f minus g of x, okay? I want you to do that really quick, and let's see if you do it correctly or if you make a careless mistake.
Ms. Davis, how was your break?
I kept kids with strep throat the whole time.
Wow.
I got one day. One day. Yeah, it wasn't.
I didn't even get a day.
I got grounded too early.
That's mid-snow time.
With strep throat kids?
Yeah, just when it's rocky. Rocky.
I slept.
All right, so what's the careless mistake?
People don't change all the, oh wait.
Don't
Yeah.
worry about the negative.
Yeah, this negative, I'm gonna use parentheses, because then it shows that I'm subtracting the whole thing. Some of y'all, what you said was, don't change all the signs, or don't carry through the negative. Those were words that I heard you say, so that was good stuff. So 2x plus 1, the opposite of a positive x squared is a negative x squared. The opposite of a positive 2x, minus. The opposite of a negative 1 is a
Plus.
positive 1. So if you only slap a negative sign in front of that function and you don't carry it through, you only subtracted the first term of the function and not the whole entire thing like they asked you
You
to.
remember that H and X thing? That's what I remember. How you had to subtract it from what the
Oh, the
function
difference
was?
quotient?
Yeah.
Yes. All right, so we start off with our highest exponent, which is negative x squared. And then you have 2x minus 2x. 0. And then you have positive 1 and positive 1 make
0.
2.
Can we still plug in?
I'm struggling today, Ms. Davis.
I am too. I taught this first thing wrong this morning, so I'm struggling too. I don't know what happened. I was sitting there looking at it on my book and I wrote it down different. Anyway.
I didn't even set my alarms last night. I just fell asleep.
Oh, I didn't mess it on. Example 3. F of x is equal to x squared, and g of x is equal to x minus 3. I want you to find f times g of x, then evaluate f times g of 4. How many answers?
2.
2. Go.
Oh, I got one answer. Is it 16? 16.
What property am I fixing to use?
Distribution.
Distributive. So what's x squared times x?
X to the third.
And x squared times -3?
Negative 3x squared.
So this is f times g of x, okay? Now that all they want me to do is plug a 4 in for my x, so this is going to be equal to
Plug it in the
4 to
calculator.
the third minus 3 times 4 squared. All right, what's 4 to the third?
64.
What's 4 squared?
16.
What's 3 times 16?
48.
And 64 minus 48?
16.
16. All right, anybody got a question?
Why does that look like 1b?
I don't know, that's my hand, we crazy. All right, so here's my next one. This is b. F of x is equal to 1 over x, and g of x is equal to x over x plus 1.
Miss Davis, you do know how to mess somebody's day up. Just put a fraction in front of them.
I want you to find f times g of x. You have a minute.
Just not writing it down.
Yes, you can. Oh my gosh, y'all, this is so stinking easy.
So easy.
Eli, I think you can pass this test.
Getting closer. You want us to find f?
Closer every time, Bailey, I've been getting further away.
F of what? Like we need to find some.
Just f times g of x.
Don't plug it in.
We're not plugging
I
anything
don't think
in.
I did this right.
I gotta hurry because the bell's about to ring.
It's a fraction.
Okay, so all we're doing is multiplying, right? Pay
Yeah.
attention, guys, the next one I work is really important. What should I do first?
Cancel out the
Yes.
Oh, darn, Nabbit, I didn't do that, man.
There's my answer.
Chump.
Miss Davis, you fake for that. How you do that? Oh.
Okay? Last one, example 4. F of x is equal to 2x plus 3. G of x is equal to 2x squared plus 5x plus 3. I want you to find, we are going to do it together because the bell's going to ring in a minute. F over g of x. Okay? So, f over g of x. All I do is put f of x on the top and g of x on the bottom. Does everybody agree?
Yes.
Yes.
Okay, so I've got 2x plus 3 over 2x squared plus 5x plus 3. Okay, now let me warn you about this. Do these 2's cancel out?
No.
No, people, you cannot do that.
Different X.
I want to factor the bottom and see if this thing will reduce. Okay? Does this bottom factor?
No.
Well, 2x squared factors into 2x and x. Plus sign means they're both at the end. I
Forgot.
got a 1 and a 3 and I'm trying to make a 5. Don't put it here because we're not subtracting. Okay? We're not subtracting. So put a 3 here and a 1 here. There's my 3x and 2x. There's my 5x. Now, does it reduce? The 2x plus 3's cancel out. What's left on the top? Do you have to write that? Yes. Y'all, there's a difference between $1 million and 1 over $1 million. Oh, what about these ones? Can I cancel these ones? No.
Wait, why did we get the same answer?
That's crazy.
I don't know. You got one right.
I didn't get either one of them right. You got them right. Now.
Okay, remember you have a worksheet due tomorrow? And I'll give you tomorrow in class to work on the review for the test.
I don't know.